Hello and welcome guys. So today we are going to solve the day 7 of May Leetcode challenge. So today we are given a problem, cousins in binary. So let us first look at the problem. So we are given a binary and it is told that the root node is at depth 0. Okay. The children of each depth k node are at depth k plus 1. Okay. So if the child is at level 1, so we would print as 1 plus or 2. So two nodes of a binary tree are cousins if they have same depth but of different parents. Yeah, as real life cousins, you would understand better. We are given a root of a binary tree with unique values. Okay, and the values are x and y of two different nodes in a tree. Return true if and only if the nodes corresponding to the values x and y are cousins. Okay, so let us look at the example. Example 1 is the root node, 2 and 3 are the parents, and 4 is the child of 2. So here root is this, and we are given two integers, two nodes, x is equal to 4 and y is equal to 3. So we have to check that 4 and 3 are cousins or not. So here we can check that 4 is a child of 2, but there is no as such as child of 3. And as we have read earlier that a cousin must be of same level but of different parents. So here is nothing in the level of 4, so here is no cousin, so we will return false. So let us look at the example 2. 1 is the root, 2 and 3 are the parents of 4 and 5. So 4 and 5 are cousins and they are in the same level and of different parents, so we are returning true. And then like this we are given the example 3, which is false. So the notice the number of nodes in the tree will be between 2 and 100, and each node has a unique integer value from 1 to 100. Okay, that's cool. So let us proceed to the solution. So the solution is basically BFS solution. So we will use the breadth first search algorithm here for printing the cousins. So first we have to take a stack. So in the stack we have to push the node value and then the child values, and then from there we have to check. So first let us first understand step by step. First we are taking a stack. So stack, we are naming stack, which will be initialized with the root value and the level. So root 0 and root the value of the root, that is root dot val. So basically root, then its level, and then the value of the root. It is basically we are initially pushing in the stack. Then we have to initialize two variables that are the two cousins. So we are naming as cousin x is equal to, we are initialize it with 0, and cousin y we are initializing with none. Sorry, not 0, none. So two cousins are created. Then you have to check further. So we have to make a for loop and loop through it, through the parents and the node sub child's node. K is the level, parent node in stack. So this is basically the for loop. Then we have to print the parents of the child. Okay, so first level is that of the root, then we have to print these two childs of root. So for that we are going to print the left child. If node dot left, then stack dot append node dot self, sorry, node dot left it will be, not dot left, then the label as said here must be in k+1 depth. So here we have to write, we have to give the label as k+1, then comes the value of the child, not dot, sorry, val. Yeah, so the left child is completed. Now moving on to the right child, like this we have to give not dot right stack dot append not dot right k+1 not dot well. Yeah, so this is initializing, so the left and the right child after the root. Now you have to check. Okay, so for that, if node dot val, that the value must be unique, right, as said in the question, equal to x, then what we have to do, initialize the cousin, means the cousin x means basically the child of x, this one, basically this one, this node, we are creating this or initializing equal to node level k, then parent value that will be linked with the parent, so parent. So this is for the x cousin, and now we will have to do for the right cousin. So if not dot val equal to y, cousin y equal to node k parent. So two childs of these nodes are initialized here. Now what remains is the checking part. So if they are at same level, so we will return true, otherwise false. Now if cousin x and cousin y and cousin x 1 equal to cousin y 1 and cousin x 2 not equal to cousin, sorry, y do not be here, cousin y 2 so we will return true. Else come out of the loop and come out of the if statement and return false. Yeah, return false. So basically here in the question you can see that each node has a unique integer value from 1 to 100, and the number of nodes in the tree will be between 2 to 100. So this line basically tells that the cousin must have the unique values for the condition to satisfy. So we have done this, we have done the checking. So let us now run the solution. Yes, pretty much runtime is 36 ms, much high. Let's submit it. Yeah, done. So this was my approach using BFS solution. So if you could think of more optimized solution, you can always comment in the comment section. I will happy to see that and take a note of that. So this was for today. Yes, it was a bit tougher than the other challenges of week 1. So you have successfully completed week 1. Stay tuned in my channel for the week 2 challenges. Till then, stay home, stay safe, and happy coding. Bye bye.